Hello everyone, this is Miss Van Hook, and in this video I'm going to help introduce how to interpret rock strata, layers of rock, in order to figure out the relative ages of different rock layers and fossils. So please have your note guide, and let's remember what fossils can tell us. Fossils give us clues about the organism itself, so like if we see this mosquito trapped in amber, we can tell things about its size, maybe what its role was in the ecosystem. Was it a predator or an herbivore? What its behavior might have been like. It can tell us about the environment itself. If we find a fish fossil somewhere, we know that there had to have been water in that place at one point in time. And by finding different fossils nearby, we can know what else lived in the same time period. It also shows us how living things are related. If we can see how different organisms lived at different points in time, we can see which animals or plants are the most ancient and which are most recent. Knowing when events occurred and when organisms lived helps us put together a picture of Earth's past. So just like this pile of laundry here, if every day I throw my clothes into that laundry basket, I know that the clothes I wore the oldest outfit that I wore, is going to be at the bottom of the laundry basket. The more recent clothes that I wore, should be at the top. And what we know about how rocks form is very similar. Sedimentary rocks, the oldest sediments will settle at the bottom, and the most recent sediments at the top. It's just like your laundry basket. Okay, and we can see that here, that erosion and weathering break down rock into sediment, and especially in a place where that sediment can't be disturbed. So the bottom of an ocean, a lake, in a valley at the bottom of a mountain, a place where that sediment can settle, and pressure over time squishes those sediments together into sedimentary rock. The older layers will be at the bottom, and the more recent layers at the top. Okay, now we really need our note guide. You'll notice that the text in your note guide is the same as what I have here, and every highlighted word will be what you fill in a blank. So knowing the age of different rock layers helps scientists construct a picture of Earth's past. Radioactive decay is typically used to find the exact age of igneous rocks using the half-life of the radioactive element found in that sample. We're going to learn more about this later, but be sure to fill in that word igneous and half-life in your notes. This type of dating is known as absolute dating. It's because it's giving us an actual age. Once the age of some rocks in an area is known, you can use the position of other rocks compared to the known rock to approximate their ages. This is known as relative dating. Using this type of dating is especially useful for sedimentary rock since it forms in layers. So absolute dating, I know an actual age when I look and see where rock is compared to one that I know the age. If it's below or above, I know if it's older or younger. The layers of sedimentary rock are known as strata. And we're going to look at the diagram below. All right. In our picture here, this layer would be the youngest, and this layer is the oldest. Just like our layers of laundry, the old outfits are buried under the one you just wore. It's the same thing. I simply look to see which layer's at the bottom, what's at the top, and I'd know this gray layer is in between the age of the top and the bottom. Okay, pause your note taking. Look at this picture with me. So rock strata tells you general information about how old a rock layer and its fossils are compared to other layers. We get a relative sense of how old something is. So we can see all these different bands of sediment. All of those are different ages of rock. The oldest layers of rock are down here by the lady's feet, and the newest at the top. Okay. The oldest layers of rock are below the younger layers. The principle of superposition states that younger rocks lie above older rocks in undisturbed sequences. So this is the fancy name for this principle, that young layers of rock are above older rocks. And we call the geologic column, it's the order of all rock layers on Earth, arranged from oldest to youngest. It contains all the known fossils and rock formations on Earth. We can see a simplified diagram of that. So all these different ages. So think how you've maybe watched Jurassic Park. That's a certain time frame in Earth's history. And we name those ages, and we can see here there are different fossils that are typically found in those places. And over here, on the right-hand side, we see there are different names for those rock layers that we find these fossils in. So as scientists find different fossils, different rock layers, they're trying to sequence everything out into what's the very oldest rock and living things on Earth to the most recent. Fossils can also help date rock layers. Fossils that are found worldwide and where species that lived for a short period of time are called index fossils and can be useful in approximating the age of the layer of rock that they're found in. So for instance, these funny looking little trilobites, they're found in this range of time. Then they went extinct. So if I find a trilobite somewhere, I can know that it existed in this time frame. If I find an ammonite or belemnite, I know something about the age that those other fossils are. So we might find a dinosaur fossil and we see an ammonite fossil nearby. We have a sense that we know that age range that fossil was found in. Right? So we find these right here, these ammonites, and this gives us a sense of how much older or younger fossils are that we find compared to them. Many index fossils are aquatic organisms, since so many rocks with fossils formed at the bottom of an ocean or lake. Remember how sediments settle, and at the bottom of an ocean or lake, they aren't disturbed. So that's why we have so many index fossils that are things that lived in the water. Often many of these creatures with shells, because the shells also tend to form nice fossils. As scientists find out exact ages of some rocks and fossils, they can use their location compared to or in other rock layers to get an estimate of their age. Unfortunately, the rock layers can be disturbed, and it's not so easy to put the pieces of the geologic column together. Rock layers can also be missing. An unconformity refers to a missing part of the geologic column. Intrusions can also occur when liquid rock from the Earth's interior melts through existing rock and cools. That would be magma, igneous rock that's melting its way through. An intrusion is always younger than the layers it cuts across. Faults can also occur in rock layers, shifting where the layers are relative to each other. Reading the story told in the rock layers is like solving a puzzle. And that's what we're going to be working on over the next few days. So to think about that idea, this cake had to exist. All these layers had to be here in order for me to cut into it, like this fault does right here. See how the gray sediment layer is shifted because of this break in the Earth's crust, a fault where earthquakes have slowly shifted where this layer is compared to that. The layers had to be there first. They have to be older in order to be disturbed. Okay, we can see this again here. Here's where that magma melted through layers that already existed. And that melting through, that intrusion, has to be younger. It has to cut into those layers that were already there. Okay, so part of what you're going to be doing today is sequencing how old certain rock layers are. And I can compare things I know in one place and another to figure out how old they are. Notice here, layer V melted into layers Y X, and W. That means this has to be younger than those layers. All right, we're going to give that some practice with that handout. Just do your best and see if you can figure it out.